Hello, and thank you for listening to today's episode of JATCast, the official podcast of the Journal of Athletic Training. I'm your host, Luke Donovan. For this second episode of the month, I will continue with the theme related to overuse injuries and discuss the findings of an article from the most recent issue of JAT titled, Impact Sound Across Rearfoot, Midfoot, and Forefoot Strike During Overground Running, authored by Mr. Ivan Pui Hung Au and colleagues from the Hong Kong Polytechnic University, Curtin University, and Western Sydney University. As a reminder, the article discussed today can be found on the JAT website, natajournals.org. And please remember that all content from JAT is open access to all readers, thanks to the funding from the National Athletic Trainers Association. First step, surveying the scene. Although not proven, it has been proposed that foot strike patterns during running may affect injuries, running economy, and overall running performance. The three types of foot strike pattern are, first, rear foot strike, which is when the first point of contact with the ground is the heel. Second, midfoot strike, defined as when the whole foot simultaneously strikes the ground. And finally, forefoot strike, which is when the ball of the foot is the first point of contact with the ground. A previous study has found that approximately 90% of recreational runners adopt a rear foot strike pattern, while 7% use a midfoot and 3% display a forefoot strike pattern while running. Other studies have found that between 32 and 68% of runners could not accurately self-report which strike pattern they use while running. The inability to accurately self-identify foot strike pattern may have negative outcomes, such as not selecting appropriate footwear and training regimens. These factors could potentially increase the risk of injury. One clinically applicable method to identifying foot strike technique in the absence of high-speed video cameras is by listening to the sound of the foot ground impact, as relationships between sound of impact and different running techniques have been identified. Therefore, the purpose of the study was to compare the differences in sound amplitude across foot strike patterns. Secondary aims were to determine differences in sound frequency and duration among different foot strike techniques and determine the relationships among the sound characteristics such as sound amplitude, frequency, and duration of the three foot strike techniques and kinetic measurements, specifically vertical instantaneous loading rate and vertical average loading rate. 30 runners were included in this study. The study consisted of one testing session, in which participants were instructed to run along a 20-meter runway at a standardized speed of 3.5 meters per second, using each of the three foot strike strategies. During each trial, where there was 10 total trials for each foot strike pattern, kinetic variables and sound characteristics were simultaneously recorded using an embedded force plate and a microphone. Here are the results. The mean peak sound amplitude for rear foot strike was 0.154 millivolts, midfoot strike was 0.384 millivolts, and forefoot strike was 0.351 millivolts. A strong association was observed between peak sound amplitude and each of the three foot strike techniques. In addition, peak sound amplitude for rear foot was significantly quieter than both midfoot and forefoot, while midfoot was also significantly louder than the forefoot technique. For sound frequency, moderate associations and significant differences were observed where rear foot had lower sound frequencies compared to the other two patterns, and midfoot strike had higher frequencies when compared to the rear foot and forefoot patterns. With respect to sound duration, a moderate association was found among each foot strike technique. In addition, the rear foot technique had a longer sound duration when compared to each of the other techniques. Finally, there were no significant relationships noted between any sound characteristics and any measures of running kinetics. This study found that midfoot and forefoot strike techniques produced a louder sound than rear foot strike, a finding that was contrary to the study's hypothesis in previous investigations. The authors attribute the difference in results to the mode in which instructions were provided. For example, in a study by Fawn et al., participants were instructed to run quietly, which resulted to these participants switching away from a rear foot strike technique. Therefore, it appeared that the midfoot or forefoot strike patterns equated to a quieter pattern. On the other hand, this study made no reference to sound, but rather instructed participants to run using each of the different striking techniques. which in turn may have represented a better mode to isolate the effects of foot strike patterns on impact sound amplitude. Another key finding of this study was that sound characteristics were not related to vertical loading rates. Therefore, other measurement equipment may be more effective, such as accelerometers, to estimate vertical loading rates. Future investigations should determine the sound characteristics of runners who naturally utilize each of the three strike patterns, or determine how footwear influences sound to aid with further developing low-cost, clinically applicable strategies to assess runners' foot strike techniques. Well, that's it for today's JATcast. Please remember to rate and subscribe to the podcast, which is available on iTunes, Google Play, Spotify, YouTube, and Stitcher. You can find out more information about upcoming podcasts and other JAT events on our Twitter, Facebook, and Instagram accounts at JAT_NATA. Thank you for listening and keep a lookout for next month's JATcast.